So my dear children, in the earlier chapter we discussed several things related to the pressure lesson, and also we identified that the two main factors which affects the pressure is the surface area and the force which is acting on that surface area. So I told you that always all the time we have to take the perpendicular force which is acting on the particular surface. But however, I told you that within our O-level syllabus, we'll be discussing only these perpendicular forces only. So therefore, it's okay to mention as force. So the force and the surface area which the force is getting acting are the two main factors that affects the pressure. So now within this chapter, we'll be discussing how to calculate the pressure by using a certain type of an equation. How to build up an equation to calculate the pressure. What are the units of pressure? And we'll be discussing some questions in calculating pressure. So those are the parts we'll be discussing within this chapter. Then after that, we'll be discussing several questions related to your textbook. Then some extra exercises for the lesson pressure. Right. So first of all, we'll see how to develop a particular equation and how to calculate the pressure. So pressure is defined as the perpendicular force acting normally on an unit area. So we know that pressure is the, right, we know that the pressure is the force which is acting on a unit area of a certain surface. Okay, already I have mentioned this thing when I was starting the lesson part. We discussed several things related to the pressure lesson. Under that, we took the definition as it is the force acting on a unit area. So my dear children, the pressure exerted by a solid object on a solid surface can be calculated according to the following formula. So as you know that the two factors are force acting and the area. These are the two factors that depends or that affects the force, right? So we can that affects the pressure, not the force, right? So force is a factor that affects the pressure. So pressure of a solid substance or solid surface, right? Pressure acting on a solid substance or acting on a solid surface is depending on the force acting and the surface area, contact surface area of the force, right? So these are the two factors that affects the pressure. So we can define the pressure thing as like this according to the given formula over here. So always pressure is equal to perpendicular force, which mentioned by capital F, division the surface area on which the force is acting, given as capital A. So capital F over capital A, right? Pressure is equal to force upon area. Okay, pressure is equal to force upon area. So in simple, you can mention it as like this: P is equal to F over A, right? So this is the basic equation that we use in calculating pressure. So we use the formula called P is equal to F over A in calculating pressure. So always remember, pressure which is getting created in a solid substance on a solid surface can be calculated by the formula P equal F over A. Here F means the pressure, here F means the force which is acting on the particular surface, and A means the surface area, the contact surface area. So this formula can be used to calculate pressure acting on any kind of a surface. So my dear children, this is the basic equation that we use to calculate the pressure in a solid substance or solid surface due to action of a certain force. Right then, The units of pressure, now we know how to calculate the pressure. Pressure is equal to F over A, force upon area, right? So now we are going to develop what are the units that can be used to measure this pressure, right? So pressure is a quantity, a physical quantity. So therefore, we should have an ability to measure it. In measuring, you know that we use units. So units of measuring length is meters, kilometers, centimeters, and so on. Units of measuring mass is kilograms, grams, milligrams, like that way. So by like that way we are developing, or we are now we are going to investigate what are the factors or what are the units that can be used to measure pressure. So first of all, we'll write down the formula. What do you mean by pressure? Then let's head for the units, how to get the units. So you know that pressure is equal to the perpendicular force. I told you that it's okay to mention as force, as always, all the time you will be getting perpendicular forces within your syllabus. So pressure is equal to force upon area. So we know that force is measured from newtons. In the earlier lesson we studied that the unit of measuring force is newtons. The international standard unit to measure a length is meters. So you know that area is created by the multiplication or by the product of length and breadth. So therefore we can mention, right? Therefore we can mention the area of a certain solid surface as meters into meters as square meters. So square meters is the international standard unit of measuring area. Always remember square meters, okay? Square meters. So square meters, m to the power 2. So you know that we can take these powers which are located at the denominator, right? If the powers are located at the denominator, we can take it to the upward by taking the negative power of it. So it can be written as nm to the power negative 2. As this one coming up, it becomes negative 2. So this unit is referred as newtons per square meter. Newtons per square meter. As this is to the power 2 to the power negative 2, we are going to define that thing as per square meter, okay? Newtons per square meter, right? So this is the basic unit that we use to measure the pressure. Newtons per square meter. Newtons per square meter. Newtons per square meter is the basic unit to measure pressure. But however, there is another kind of a different unit to measure the pressure. This unit was introduced to honor a certain scientist who did several experiments and findings on the topic related to pressure, right? So in the next year, in grade 10, when we are learning about the liquid pressure, definitely you will come across with this scientist. So this scientist is named as the Blaise Pascal. So he did several findings or several things, several experiments related to the pressure. So therefore, to honor the scientist Blaise Pascal, this newtons per square meter unit is also referred as pascals. pascals, right? Pascals. Pascals, which goes by the symbols capital P and simple A. Pascals. So normally we measure pressure by using pascals. Pascals means newtons per square meter. There is no difference in it. To honor the scientist, that scientist who was named as the Blaise Pascal, we define 1 newtons per square meter as 1 Pascal, right? To honor him. So my dear children, there are 2 units to measure. Okay, there are 2 units to measure pressure. First unit is newtons per square meter. Newtons per square meter. Okay, that's the fundamental unit. However, there is another unit which is called as pascals, right? Pascals is also referring to 1 newtons per square meter as well. But however, right now, without the fundamental units, by using another different kind of a unit, we can measure pressure. That unit is pascals. However, my dear children, when you go deep inside to it, 1 Newton meter is always equal to 1 Pascal. There are 2 different units, but however, the values are same. There is no change in it. Okay. 1 newtons per square meter is equal to 1 Pascal. Right? Newton per square meter, 1 is equal to 1 Pascal. So here, newtons per square meter means, especially this thing is referred as pascals. Like in grade 8, we discussed that if you are going to measure the power of a certain electrical equipment, we measure the power by using the value called watt. Watt means amount of joules consumed within 1 second of a time period. So 1 joules per second is equal to 1 watt. In the same way, 1 newtons per square meter is equal to 1 Pascal. Okay, right. So my dear children, the basic fundamental unit is newtons per square meter. Newtons per square meter. Right, this unit is also named as pascals. Pascals. So here we go then. The standard unit of measuring pressure is Nm minus 2. Nm minus 2. Nm to the power minus 2. Okay. So this is also referred as newtons per square meter. Newtons per square meter. It is also known as pascals. It is also named as pascals, right? It is also named as pascals. In honor of the French mathematician Blaise Pascal. So I told you that Blaise Pascal was a scientist and a great mathematician, right? So he was the first person, right? He did several experiments related to pressure. So to honor him, right? To honor him, this was named as what? The Pascal, right? The newtons per square meter thing which used to measure the pressure was named as pascals. So here it is given that the unit of pressure was named after him, right? This unit of pressure was named after him to honor him. So 1 newtons per square meter can be given as 1 Pascal, right? 1 newtons per square meter can be given as 1 Pascal, right? So in the earlier also I told you that when I was developing the units, 1 newtons per square meter is always equal to 1 Pascal. So my dear children, these are the 2 basic units that we use to measure the pressure. However, the 2 units are same. We give out a special name as pascals for newtons per square meter. That's the difference, the only difference which can be identified here. Both newtons per square meter and Pascal thing refers to the same. Okay, it refers to the same. Right then. So, right. So now let's move on to the next question, next slide, and we'll observe. So I have we'll observe how to simplify several questions by using the formula related to pressure and how to get the units of them. So we'll see what are the questions given then. So it is given what is the pressure exerted on a surface of 2m squared. So that means the surface area is 2 square meters. 2 square meters. When a normal force of 300 Newton is acting on it, right? So it is given that the pressure exerted on a surface, you have to calculate the pressure exerted on a surface that has an area of 2 square meters when a normal force of 300 Newton is acting on it. So we'll calculate. What is the formula, my dear children? Formula is simple. Pressure is equal to force upon area. Always remember, when you are substituting the values, force should be in newtons and area should be in square meters, not in centimeters. It should be in square meters. So force is equal to, here force is given 300 Newton upon area is given as 2m squared. So when you divide 300 by 2, answer is 150 newtons per square meter. Newtons per square meter. Don't forget about that -2 when you are taking the pressure. Okay, that -2 indicates the per square meter thing. So therefore you have to definitely include that negative part over there, right? Otherwise your answer is wrong. So this can be also written as 150 pascals. So this is our final answer. If you want, you can keep the answer as newtons per square meter, but it's better to keep the answer as pascals. So 150 pascals is our final answer, right? 150 pascals. Then another question is given. Weight of a cubic box is 400 Newton. It is kept on a horizontal plane surface. Pressure exerted by the box on the surface is 200 Pascal. What is the contact area of the surface of the box? Right, so here you can observe the box which is given. Now it is saying that it is going to exert a force due to the weight of the object. It is exerting a force of how much? 400 newtons. Exerting a force of 400 newtons. That's the weight of the object, right? You know that each and every object, right? Each and every object has a certain weight. Weight is the gravitational pull given out by the earth. So therefore each and every object is pulled towards the earth by a certain force. So that force is the one which is referred as the weight of the object. So when you are standing on the ground also, you are exerting certain amount of a pressure to the ground because of your weight, right? The earth is pulling your mass towards the ground. So that pull exert a force on the ground. As your legs have a certain surface area, right? You are creating a certain amount of a pressure on the earth. So my dear children, upon having a 400 Newton of weight, you need to find out the pressure exerted by, you need to find out the surface area which the box is contacting. If the pressure given by the box on the ground is equal to 200 pascals. So we go for the basic formula, right? We'll go for the basic formula. The basic formula is pretty much simple. What is that? Pressure is equal to force upon area, right? Pressure is equal to force upon area. So we'll write down the formula first. P is equal to F over A. Now we'll substitute the values and we'll calculate the area. So I'll take the area of this contact surface as just A because we don't know it. The pressure acting on the surface is given as 200 pascals. 200 pascals. That's the pressure. So we can substitute the values. 200 newtons per square meter is equal to force. Force is 400 newtons upon area we don't know. Area we don't know. Now what do you have to do, my dear children? You place 1 over here. And now let's do the cross multiplication. I think you have heard about the cross multiplication in an equation. If you have two fractions like this, you can do the multiplication, the cross multiplication, where you take this one to be multiplied with the top part, the numerator, and this denominator with the numerator over here. So A times 200, I'll take the slide somewhat up. So A times 200, it is equal to 200A. Here this side is getting equal to 400 times 1, 400. So to find out A, now what do you have to do? You need to divide both the sides by 200. So we'll divide both the sides by 200 now. 200 to 200 is getting cancelled. Here 2 zeros to 2 zeros are getting cancelled. Here 2 times 1. Here 2. Answer is 2. Now what is our unit? What is the unit, children? You know that we substituted the international standard units. For force, we applied the Newton value for force. For pressure, we applied pascals. That's the international standard unit, or newtons per square meter. So if you substitute international standard unit in an equation, for the unknown term also, you will be receiving the same international standard unit which you are going to measure that quantity. Okay. So you know that area is being measured from square meters. I told you at the beginning of our chapter, area is measured from square meters. That is the international standard unit of measuring area. Okay. So here you substituted by using the values newtons and newtons per square meters or pascals. So therefore, my dear children, the unit of measuring area is also square meters. Square meters, the international standard unit of measuring area, square meters. This is our answer, right? This is our answer. So for the earlier case, when you substitute it with the international standard unit, you can get the answer from the international standard unit like this. See, 2m squared. See here, 2m squared. That's the area. International standard unit of measuring area is square meters. Then here 300 Newton. 300 Newton. Once again the international standard unit of measuring force, newtons. So in that case, my dear children, you will be getting the international standard unit of measuring pressure, which is pascals or newtons per square meter. In the same way, when you use the international standard unit for the substitutions like this, you will be getting the international standard unit for the unknown term as well. So here you substitute this thing by using pascals, which is the international standard unit of measuring pressure. Here this thing, the force, you substitute with newtons, international standard unit of measuring force. So when you simplify and get the answer for area, you will be receiving that answer from international standard unit of measuring area, which is square meters, right? So when you are doing a certain calculation, don't think about the units. You just substitute it with the formula, then check whether you have substituted that thing by using international units or not. If so, it is also equal to the international unit like this. Okay? Right. So these are the questions, some questions related to pressure. So we'll be doing some several examples and other types of questions when you go further with our lessons and during also our exercises, right? In extra exercises also, you can find several questions in calculating pressure and also surface area and also force as well, right? So these are like basic examples to how to use the or how to utilize the formula P is equal to F over A. Right then, so we'll see what are the other contents in the lesson then. So here now we came to the final lesson part, the final topic of the lesson, right? The final subtopic is changing the factors affecting pressure as needed. So you know that pressure is a certain concept or it's a certain type of a quantity, right, that acting on a certain surface. I told you that pressure is a scalar quantity. It's because that there is no certain direction of pressure. Pressure is acting all around the surface. For each and every place, we can observe the pressure, right? If a certain force is acting on a certain surface, the pressure is distributed all around the surface. So therefore, it is a scalar quantity. It doesn't have a direction of action, right? It is a scalar quantity. Pressure is a scalar quantity. So my dear children, you know that upon exerting pressure, the contact surfaces are having a certain type of a tension. So that tension can be minimized, or if you want, you can increase it to make our work easy. So within this part, we'll be discussing how to change those factors in order to increase or decrease pressure. Okay, how to control these factors in order to increase or decrease pressure to make our work very easy, right? So now let's see what are these instances where we increase pressure and where we decrease pressure to make our work much easier. So first instance is given in here. When cutting something, it is easier if the knife is well sharpened. If the knife blade is well sharpened, right? If it has like a very thin blade, shouldn't be blunt. Blunt knives are very difficult to use. We can't cut materials or stuff by using a blunt knife quickly. It's because that if you take a knife, the blade of the knife is having a very thin layer of a surface area. That's why we are going to sharpen it very well. If the surface area is very thin or if the surface area is very less, upon exerting a simple force, it's going to exert a greater pressure on the particular surface. So you can cut it very quickly without any trouble. So in this time, we reduce the surface area by sharpening the blade of the knife. Okay, sharpening the blade of the knife and we are increasing the pressure. How do we increase the pressure? Upon sharpening the blade, we are decreasing the surface area which is going to contact. By that way, we are increasing the pressure. Right? By that way, we are increasing the pressure. So, my dear children, it is very helpful, right, in this case to have or to exert a greater pressure in cutting these materials. So, even you are given with a figure, right, you can take this and you can cut it very quickly by using a very sharp knife. So, here let's see the definition then, the explanation. When sharpening, the knife edge becomes very thin. It can exert a high pressure on the object. So, the object can be cut thinner and easier. So, like I said, when you are making the blade very sharp, when you are making the edge very sharp, it's going to exert a greater pressure as the surface area is very low. You know that surface area and pressure has opposite relationship. These two factors has an opposite relationship. Opposite relationship in the main, right, in the sense, what do you mean by opposite relationship? When one quantity increases, right, when one quantity is going to increase, when one quantity increases, the other decrease. When one quantity is going to increase, the other is going to decrease. When decreasing a certain quantity, the opposite one is also is going to increase, right? So that kind of a relationship is called an opposite or inverse relationship. So when you are reducing the surface area, pressure is going to increase. That's why we can cut these materials very easily when you are using a sharper blade, okay, in a knife. Then the next one, the bottom of the skates used by skiers is made sharp like a knife edge. Now this instrument is called the skier, right? So these are special type of like shoes, right? Skates. So it's not the skiers. This is called as the skate. The person who is going to wear these stuff and to travel on the snow are called as the skiers, right? Skiers. So these skate shoes, they are made so as to have a very thin, like here you can observe, it's like a blade, a knife. So the skiers are using these special kinds of shoes to travel on snow very quickly. It's easier to travel by using these kinds of skates, right? So let's see what is the reason for having this kind of a sharp edge, right? So the bottom of the skates used by skiers is made sharp like a knife edge. Because of this, a high pressure is exerted on ice. Now you know that if it is having a less surface area, I mean like if it is very thin, the surface area is very less, so it's going to exert a greater pressure on the ground. Here especially on the snow or on ice, right? On ice, it is exerting a greater pressure. So upon giving out a greater pressure, ice is going to melt very quickly and it's going to create a liquefied water line. You know that water is very slippery. So upon having very less, right? Upon having very less surface area on the skate, right? Upon having very less surface area on the skate, right? The person or the skier can very easily slide past on ice and travel very quickly, right? Even in like games, winter games, you could observe these kinds of things, or this sport which is referred as the skating, ice skating. Okay, so here the shoe is made to have a knife edge bottom in order to increase the pressure and melt a layer of ice when the skier is traveling on ice. So it helps to slide past on ice very quickly as the water is very slippery. So here, when the skier is skating, that high pressure makes the ice liquefy and form a slippery surface. See? So it helps to create out a slippery surface so that the skier can travel very quickly and easily. This is why the skating shoes have a very thin blade-like edge right there. So here you can observe a loaded truck, right? You can see there is a heavy load within this truck. And once again, unlike normal vehicles, these trucks have large number of wheels. Now, if you count the number of wheels in here, it has like 1, 2, 3, 4, 5, 6, and the other side also there should be 6. So 6 all together there are 12 wheels, right? There are 12 wheels. 1, 2, 3, 4, 5, 6. Then get the other side also 6. 6, there are 12 wheels altogether. So loaded trucks, most of the times like containers, lorries, they have these large number of wheels at the either sides of the vehicle. So what's the purpose of having these large number of wheels? It's because, my dear children, when you increase the number of wheels in a vehicle, what happens here is you can decrease the pressure. How come? Because larger surface area is getting contact with the ground. Larger surface area is getting contact with the ground. As there are 12 wheels, the contact area with the ground is very high. What will happen if there are only 4 wheels? Then the contact area is going to be very less. You know that each tire has some amount of a surface area. So upon having several tires, right, now here like 12, if we assume that the contact surface of one particular tire is 1 square meter, then these 12 tires are going to contact on 12 square meter of a surface area. 12 square meter. How come? Because 1 times 12. If one is having 1 square meter, then 12 of them will have 12 square meters. But what will happen if it has only 4 wheels? Then 1 times 4, only 4 square meters. Now you can see that upon having 12 wheels, 12 square meter of a contact surface can be observed. But upon having 4 wheels, we can observe only 4 square meter of an area. So what's the purpose of increase in this contact surface area? Why does these heavy containers or lorries increase the surface area? It's because that you know that heavy loads are loaded to a truck or to a container. So upon having heavy loads, the weight given on the tires will also increase. So upon having very high weights, there is a possibility that the road will get damaged, or there might be, or the vehicle also might get damaged. There is a possibility. So to avoid those complications, large number of tires can be observed. So this will increase the surface area and decrease the pressure acting on the ground as well as on the vehicle, right? So here, roads can be easily damaged because of the high pressure exerted by heavily loaded trucks and the container carriers. Obvious, right? It's because if it is heavily loaded, the weight is very high. If it has a very high weight, then the road could damage. To avoid this, such vehicles are made with a large number of wheels. Then the contact area with the road is increased and the pressure is decreased. Hence, the damages to the roads are minimized. So, this is how we are going to increase or decrease, right? This is how we are going to increase or decrease the factors we need in order to increase or decrease the pressure which is acting on a certain surface. Sometimes, right, we can increase the pressure. Sometimes we can decrease the pressure to make our work easy. Now, in the earlier cases, we increased the pressure. In this case, we decrease the pressure to make our work easy. Right. So, my dear children, these are the areas that we need to discuss within this lesson. So, we discussed several things related to the pressure lesson. We identified and I have given you a simple introduction on what do you mean by the pressure. We discussed what are the factors that affected the pressure, and we developed a certain formula to calculate the pressure. Then we found out that pressure can be measured by using the units called Pascal and Newtons per square meters. Then we changed the factors affecting the pressure to make our day-to-day works easy. Okay. So, those are the things that we learned within this lesson. Right. So, we have came to the end of the theoretical parts related to the pressure lesson. Now, it's time to discuss a summary related to the lesson. So, pressure. Pressure is defined as the perpendicular force acting on an unit area. So, it is the force, the perpendicular force acting on a unit area. This is called as the pressure, right? Perpendicular force acting on a unit area. That is the definition for pressure. The pressure exerted by a solid object on a solid surface depends on two factors. Now, we discussed the two main factors that pressure is going to depend on. Those two factors are, my dear children, number one, perpendicular force acting on the surface, the perpendicular force acting on the surface, and the second one, surface area on which the force is acting, surface area on which the force is acting. These are the two main factors that affects the pressure. Then pressure can be calculated by using the formula, right? Pressure can be calculated by using the formula perpendicular force, which is in simple we can mention as force, upon the surface area which the force is getting contacted with, area A. So, P is equal to F over A. This is the formula. Then the unit of measure in pressure is Nm to the power negative 2. Nm to the power negative 2 means Newtons per square meter. Newtons per square meter is getting created like this. Newtons over square meter. Newtons over square meter. This is also referred as pascals to honor the scientists who did several experiments related to the pressure. Blaise Pascal, right? To honor him, we define this thing as pascals. Newtons per square meters is defined as pascals. Then, pressure can be increased or decreased by manipulating the factors which are effect on pressure. Manipulating means changing as we need. So, by changing the factors like surface area and the force, okay, we can change the pressure acting on a certain surface. So, these pressures can be changed to make our work quite easy. So, it can be, we can increase the pressure if we want. We can decrease the pressure if we want to make our day-to-day works quite easy. So these are the things that we learned under the lesson pressure, my dear children. Now, this is the end of our lesson, the theoretical parts. Like I said earlier, this is the end of our theoretical parts related to the pressure lesson. So in the next chapter, we'll be discussing several questions related to the pressure lesson. As usual, first of all, we'll be discussing several questions given in your textbook. Then after that, we'll be discussing several questions, several extra questions related to the lesson. So I'll hope to meet you within our next chapter to discuss the questions in your textbook.